Hello, good morning, students. Now today we are going to start the crystal defects, or that is what is known as imperfections in solid. Crystal defects or imperfection in solid. Let's have a look over. The real naturally occurring crystalline substance do not have perfect crystal structure. So whatever the real are there in the nature, they don't have the real crystal structural. They have some disorder, irregularities in the stacking of atoms. So when you are putting the atoms, there will be some irregularity. Such irregularities in the arrangement of the constituent particle of a solid crystal are called defects or imperfections. Defects are created during the process of crystallization. So when the aqueous solution is going to crystallize, solidified, at that time that is defects is created. The imperfection are more if the crystallization occur at the faster rate. The imperfection are more if the crystallization occurs at the faster rate. It means that the defects can be minimized by crystallizing out by slower rate. Okay. So if the crystallization is faster, defects is more. If crystallization is slower, defects is less. In fact, ideal crystal with no imperfection are possible only at the absolute zero temperature. Above this temperature, no crystalline material are 100% pure. This contain defects. Okay. Whatever be nature of the crystal defects, electrical neutrality of the solid is maintained. Whatever be the nature of the crystal defect, electrical neutrality means that is number of positive charge and number of negative charge of the solid is maintained. It is important to note that sometimes defects are to be intentionally created. It is important to note that sometimes defects due to intensely created for the manipulating the desired properties in crystalline substance. Okay, defects are to be intensely created for manipulating the desired properties in crystalline solids. Now students, let's have a look. There are three types of defects: point defects, line defects and plane defects. Only point defects will be discussed in this chapter. Let's have a look over the point defect. These defects are irregularities produced in the arrangement of the bases at lattice point in the crystalline solid. There are three major classes of point defects: stoichiometric point defects, impurity defects and non-stoichiometric defects. So three types are there. Firstly, we are going to understand stoichiometric defect. Chemical formula of the compound show fixed ratio of number of atoms or the number of cation and anion. This fixed ratio is the stoichiometry of the compounds. In stoichiometric defect, the stoichiometry remained unchanged. In other words, the ratio of number of atoms or number of cations and anion compound remained the same as represented by its chemical formula. There are four types of stoichiometric point defects, that is vacancy defect, self-interstitial defect, Schottky defect and Frankel defect. So first of all, we are going to understand the vacancy defect. During the crystallization of a solid particle missing from a regular side in the crystal lattice, the missing particle created a vacancy in the lattice structure. Thus, sometimes lattice sites are vacant because of the missing particle as shown in figure 1.12. The crystal is then said to have the vacancy defect. The vacancy defect can also be developed when the substance is heated. So here there is a particle is missing, here is the particle is missing. So this is what is vacancy defect. Due to the absence of particle, the mass of the substance decreases. However, the volume remains unchanged. As a result, the density of substance decreases. Now, the self-interstitial defects in the elemental solid. Interstitial site in a crystal are the space void in between the particles at the lattice point. When some particles of the crystalline element solid occupy interstitial site in the crystal structure, it is called interstitial defect. Means the space between the 4 atoms or 6 atoms, that is what is known as interstitial defect. The defects occur in the following two ways. The firstly, an extra particle occupy an empty interstitial space in the crystal structures as shown in figure. This extra particle is same as those are already present in the lattice point. So here is the extra particle is present. Okay, so this is creating, thus extra particle increases the total mass of the substance without increasing volume, hence the density increases. Secondly, in the element, solid particle gets shifted from the original lattice point and occupy the interstitial space in the crystal as shown in below. So that is from here to here it is transverse. So that is what is also the defects. It is interesting to note that this second case, because of the displacement of particle, a vacancy defect is created as the original regular lattice side. At the same time, interstitial defect will result at its new position. We can therefore say that this defect, therefore combination of vacancy defect and interstitial defect. Okay, this defect preserve the density of the substance because there is neither loss or the gain of substance. Now let's have a look over the Schottky defect, students. Okay, so we'll make another video, student. Thank you so much for watching.